1 bucket. 5 minutes to set up. 48 hours later, you have twice as much protein as you started with. No soil, no weeding, no waiting months for harvest. NASA calls it one of the most protein-dense plants ever tested, and families in Thailand have eaten it for centuries. They call it eggs of the water. 2 things explain why almost nobody in the West grows it. One involves water. The other involves a lie we've been told about where protein comes from. By the end of this video, you'll know the exact 5-minute setup that turns any container into a protein factory. But first, you need to understand why this plant was hidden from you in the first place. Welcome back to Secrets Beneath Nature. If you've ever wondered why growing your own protein feels impossible while corporations profit from your dependence, what you're about to hear changes everything. For generations in Southeast Asia, families harvested tiny green spheres from still water. No farms, no tractors, no fertilizers, just a bucket, a pond, or a ditch filled with sunlight. Grandmothers skimmed floating green grains from ponds, dropped them into omelets and soups, and fed entire families. They called it kai nam. Their children called it breakfast. The plant floated silently on calm water, barely visible unless you looked closely. It needed nothing except sunlight and a little nutrients, yet it delivered something modern agriculture told us should be impossible: complete protein, all essential amino acids, growing faster than any conventional crop. Then a scientist noticed what indigenous communities already knew. Researchers studying aquatic plants saw a species so small dozens could fit on a fingernail, yet so fast-growing it defied every agricultural model. When NASA searched for crops to grow in space, they tested lettuce, wheat, soybeans, potatoes, and dozens of engineered candidates. One plant outperformed them all. The same plant Thai villagers scooped from buckets became a leading candidate for feeding astronauts in orbit. The same plant Western science ignored for decades became a centerpiece of space food research. We've been told protein requires vast land, heavy machinery, industrial fertilizers, and long growth cycles. This plant breaks every rule. Picture this. Day 1. A thin green film floating on still water, barely noticeable. Day 3. The surface is completely covered in a dense green carpet. Day 5. You scoop out handfuls and the container looks full again the next morning. It replaces itself overnight. Each frond is smaller than a grain of rice, bright emerald green, soft and silky when fresh. No visible roots in most species, just pure living nutrition floating on the surface. In Thai cuisine, it's folded into omelets, stirred into soups, and eaten fresh. The taste is mild, clean, slightly nutty. Dry it into powder and you hold something with more protein per gram than most foods in your kitchen. Now the numbers that make no sense until you see them. Scientific studies show duckweed protein ranges from 20 to 45% dry weight. Beef averages around 26% protein. Eggs about 13%. Soybeans around 36% on a good day. Some duckweed species reach 45% crude protein with a complete amino acid profile that meets or exceeds World Health Organization requirements for human nutrition. Most of this protein is rubisco, the most abundant protein molecule on Earth. The same engine plants use to convert sunlight into food, concentrated into something you can eat directly. Under favorable conditions, duckweed doubles its biomass in 48 to 72 hours. Some species can double in under 24 hours. Compare that to soybeans that need 90 days, or cattle that need more than a year. This plant doubles before most people remember to water their houseplants. And the productivity numbers destroy modern agriculture. Duckweed can produce more than 2,000 kilograms of protein per hectare per year, compared to about 300 kilograms for soybeans and less for corn. Under controlled conditions, researchers have measured up to 10 to 18 tons of protein per hectare per year. One small pond can outproduce entire fields of industrial crops. The environmental impact is even more shocking. Duckweed produces a tiny fraction of the carbon emissions of meat. It needs no tractors, no pesticides, no farmland. It grows on water that would otherwise sit unused. So why don't you grow it? Why isn't it in every backyard? 3 reasons explain why this knowledge disappeared. First, it looks like pond scum. Industrial agriculture values large, photogenic crops. Cornfields look impressive. Floating green dots do not. No one brags about their bucket of microscopic plants. Second, it cannot be patented in its natural form. It reproduces by splitting in half. No seed company can control it. No machinery company can sell specialized harvesters. No middleman can stand between you and your protein. Third, the industrial food system depends on complexity, long supply chains, processing plants, distribution networks. A plant that grows itself in any container threatens the entire model. But in Thailand and other parts of Asia, this knowledge never disappeared. Wolffia, the smallest flowering plant on Earth, has been eaten for centuries. It grows wild in ponds and ditches. While Western universities ignored it, villagers harvested it daily. Researchers later discovered the same species growing unnoticed in American ponds, within miles of major universities, hidden in plain sight. Then space travel changed everything. NASA needed food that grows fast in small spaces with minimal inputs. Duckweed suddenly mattered. It thrives under artificial light, produces antioxidants, and grows in closed systems. Experiments showed a few hundred grams could meet an astronaut's daily protein needs. Now here is the 5-minute setup. You need any shallow container that holds water, a 5-gallon bucket, a plastic bin, a kiddie pool, even a baking dish on a windowsill. Shallow and wide is best, because duckweed grows on the surface. 3 inches of water is enough. More surface area means more growth. Use rainwater if possible. Pond water is ideal. Tap water works if you let it sit overnight so chlorine evaporates. The pH should be between 6 and 7.5, which most tap water already is. For nutrients, fish tank water is perfect. Fish waste provides nitrogen. If you don't have fish, dilute any balanced liquid fertilizer to 1/5 strength. Even a decaying leaf can provide nutrients. Duckweed needs very little. Add your starter duckweed to cover about 10 to 20% of the surface. A single tablespoon can seed an entire bucket. Place it in bright indirect light for at least 6 hours a day. A sunny window or shaded patio works. Ideal temperatures are between 60 and 90 degrees Fahrenheit. That's it. Walk away. In 2 to 3 days, the coverage doubles. By day 5, you can harvest. Skim half the surface with a strainer. Rinse it, and use it fresh or dry it into powder. Leave the rest to regrow. One warning. Never dump duckweed into natural waterways. In some regions, it can become invasive. Compost excess. Feed it to chickens, fish, or livestock. Farmers have cut feed costs dramatically using duckweed, and backyard chickens produce deeper orange yolks within weeks. Commercial interest is exploding. Companies are selling duckweed protein as premium supplements. Venture capital is pouring into water lentil protein startups. What villagers harvested for free is now sold as a superfood. Here is what they never wanted you to understand. Protein independence does not require farmland, wealth, or industrial systems. It can float in a bucket on your windowsill. The solution was always in neglected ponds and forgotten ditches. Thai grandmothers knew it. NASA scientists know it. Now you know. If this changed how you see food, watch the next video.